Hello and welcome back. My name is Amir and this is Project Euler series. This is puzzle number 27. So let's go and see what we are facing for today. Right, so it's quadratic primes. Euler has discovered a remarkable quadratic formula like this, and it turns out that this will provide 40 primes for the consecutive integers from 0 to 39. So if we say 0 to the n plus 0 plus 41, it's a prime. Then 1 to the 2, then plus 1 plus 41 is a prime, and so forth and so on until we get to 39. And for n equals to 40, it's divisible by 41, and then it's not a prime. Right. Then there is another one, so it's n2 minus 79n plus 1601. This is prime. That will provide 80 primes from 0 to 79, and the coefficient, like minus 79 times this number, is this number. If we have this form where a is less than 1000, the absolute value of n is less than 1000, so a is from minus 1000 to plus 1000, and b is less than or equal to 1000. Actually, a is from minus 999 to positive 999, and b is from 1000 to 1000, and b is from minus 1000 to plus 1000, where n is the modulus or absolute value of n, right? As we said here, find the product of the coefficients a and b for the quadratic expression that produces the maximum number of primes for consecutive values of n. That was a mouthful. So right, so what should we do is that we would go one for loop for a from 1000 to plus 1000, and one for b the same from minus 1000 to plus 1000. Then for each pair of a and b in that for loop, we would get the length of the primes that they provide, and we check if that length is bigger than the length that we have already found. Then we would substitute a and b as the values that are biggest right now, and otherwise we would go to the next one. So yeah, that would be pretty much it. So let's get to the code. I would have three different variables. One is the candidate number that we found, one is the a that we have found, and one is the b that we have found. So now I need to have these for loops. So I need the product of the coefficients. So right, found a times found b. So like this. Now I need to get the length of these two values. So let's write that function. So right, this should be our function. It's get length. So we are going from n equals 0, and then we'll go to a loop. We calculate the formula as written here, and if the value that is provided is less than 0, which will be not a prime or is not a prime, then we would return the n. Otherwise, we would add 1 to the n and then go to the next and next and next, and we will go on until we get to a number which is not a prime. So right, that's about it. I just need to have this function isPrime. Actually, I don't need to write it. I already have it in my functions. And how to get to this function, I will provide a link in the description here if you want to check that. I will just copy and paste it from here. Right, so this should be working fine. Let me check. This is the number that we get. Let's see. Yeah, this is correct. So thank you for watching. The code is always available on my GitHub, and see you in the next video then.